Hi, I am Arun. I'm from University of Georgia, and I've been working with Hyrel in the last few months. And Dr. And Carl, CEO of Hyrel, gifted a printer for us for to use for the academic purpose. So this is the Hyrel's MEW, Melt Electro Writing. So if you can split MEW into two, like melt plus electrowriting. So it is kind of like melt extrusion plus electro spinning kind of technique. And one difference between the usual additive manufacturing and then the MEW is it can able to print like high resolution structures, which a normal like a extrusion based 3D printing can't do. So how it can print high resolution is, so we are going to have like a voltage supply over here. So through this voltage it's gonna, so we have a melt system over here. It's going to melt the polymer, and once the polymer is in a viscous state, we uses the electric field to pull the polymer and stretch and form like a cone like structure, and it's going to print like a very fine high resolution thin lines out of it. But why we need high resolution? Because especially in terms of biomedical or tissue engineering applications, we need to mimic the cells structure. The cells are usually in size of like few microns. So to achieve that kind of resolution, we need a high resolution 3D printer like MEW. And in our lab, so we are working in Dr. Keenan Song's lab. So our lab name is Advanced Material Advanced Manufacturing Laboratory, and we use MEW for a lot of different projects. So one of the main project we are currently working on is related to tissue engineering, and one of my colleague is gonna share his project's idea and what kind of structure he's gonna print with MEW and so on. Yeah. Thank you.